In this video, I will discuss a JEE Advanced question from the topic Newton laws of motion. First, I'll give some basic idea. Consider this inclined plane and a block of mass m on top of it. What are the forces acting on this plane? Earth is pulling it down, so there will be a weight mg. On the realistic surface, it will have some friction, so there will be a friction force acting on this block. And what is the direction of the friction force? In this particular case, since there is no other force acting on this block, the weight component acting along the plane in the downward direction is mg sine theta, and the normal component is mg cos theta. And there's a contact between this block and the surface, so that will give a normal reaction perpendicular to this plane of contact. So this is normal reaction. So along the plane, there is only one force acting on it, which is mg sine theta, which is trying to pull it down. So the direction of the friction force in this case will be upwards. So the direction of the friction force. Now the question is it possible for the direction of the friction force to be reversed? Can the friction force act along this direction? Is it possible? If I apply an external force on this block in this direction, if external in the upward direction, then if this upward force is of sufficient magnitude, there will be a net force acting in the upward direction. The block will try to move up, then friction force will try to act downwards. So this is possible if there is an external force acting on the block in the upward direction, and it should be of sufficient magnitude. This thing should overcome this mg sine theta, and the net force should be acting upwards. For example, if this mg sine theta was, say, 5 Newton, the downward component force, and this upward force, external applied force, if we say 1 Newton, then the friction force in this case will be still upwards. So in this case, the friction force will be upwards because there is a net downward force of 4 Newton. But suppose I increase this applied force to say 4 Newton, then also there is a net downward force, still the friction force will be downwards. But if I make this 6 Newton applied force along the plane in the upward direction, then the block will try to move up. So then the friction force direction will reverse to downwards. And also this friction force magnitude in this case will be 4 Newton, because 4 plus 1 will balance this 5. Here in this case, the friction force upwards will be 1 Newton. Here in this case, there is upward net force of 1 Newton. So the friction force will be downwards of magnitude 1 Newton. So the friction force magnitude is variable, and also direction is also variable. So friction is called self-adjusting force. Because the magnitude and the direction of the force depends on the net force, external force acting on it. But the friction direction is always try to oppose the relative motion between the block and the surface. With this understanding, we can solve this JEE Advanced question. This is the question. A small block of mass 0.1 kg lies on a fixed inclined plane PQ, which makes an angle theta with the horizontal. The horizontal force of 1 Newton acts on the block through its center of mass as shown in the figure. The block remains stationary if take G equal to 10 meter per second square. Option A, theta is 45 degrees. Option B, theta greater than 45 and friction force acts on the block towards P, that is downwards. Option C, theta greater than 45 degrees and friction force acts on the block towards Q. Option D, theta less than 45 degrees and friction force acts on the block towards Q. This is a simple question. You can pause and run this question. So you have to figure out the forces acting on this block. One force is the weight of the block, which is mg vertically downwards because gravity force is downwards. And applied force 1 Newton is there. And there will be normal reaction between the surface of the block and the wedge. So this angle is theta. This is basic of inclined plane. And this angle is also theta. Parallel lines. Okay. So along the plane, this mg sin theta will act down the plane. And this 1 Newton applied force, 1 cos theta will be upwards and 1 sin theta will be normal to the plane. So in the upward direction, it is 1 cos theta. So along the plane there is no other force. Of course there is friction force. Friction force is there. Okay, so leaving out the friction force, these are the two forces. So one possible case is these two forces are equal. Case 1, 1 cos theta, upward force equal to the downward force, mg sin theta. Is this possible? And if it is possible, for what angle? Mass is given as 0.1 and g is 10 sin theta. So this is 1. So cos theta equal to sin theta, which implies theta is 45 degrees. So when inclination of the plane is 45 degrees, the downward force, which is the weight component, the upward force component, the upright force, both are equal. So there is no net force acting on this block. So the net force, which excluding the friction, is 0. So the block will not move. So it will be stationary. So option A is true. The block remains stationary if theta is 45 degrees. Let me take the second case. Where the downward force mg sin theta is dominating 1 cos theta. Is this possible? Mg is 1 because mass is 0.1, g is 10. So sin theta is greater than cos theta. This means theta is greater than 45 degrees. Because if you remember the plot of sin and cos in the first quadrant of the 90 degrees, theta, sine will go like this. This is 90 degrees, this is 0 degrees. This is sine theta, and cos theta is 1 for 0 degrees. After that, it will drop down to 0. So this is cos theta. So both will be equal at 45 degrees. So sin theta is greater than cos theta means the angle is greater than 45 degrees. And obviously less than 90. We are considering only the case where theta varies from 0 to 90. Greater than 90 does not make sense. So this means theta is greater than 45 degrees. So in this case, the net downward force will be mg sin theta minus 1 cos theta. Mg is 1. So it's sin theta minus cos theta. So the net force is downwards. So friction force will be up the plane. Because there's a net force downwards, the block will try to move down. Friction will opposite relative motion should be acting upwards. And this point is given as P, and this point is given as Q in the question. In the question they have mentioned the lower point as P, upward point as Q. So in this case too, the friction is towards P. Friction force is towards Q. So this is theta greater than 45 degrees. So when theta is greater than 45 degrees, the friction force acts on the block towards Q. So C is the correct option. A is true, we already checked. B is not true. Because if C is true means B is not true. And the third case is the upward force is dominating. Upward force is 1 cos theta. It's greater than the weight component along the plane downwards. So this means cos theta is greater than sin theta. Cos theta is greater than sin theta means the angle should be between 0 and 45 degrees. So theta is less than 45 and greater than 0. That's obvious. So in this case, there is a net force in the upward direction, which is equal to 1 cos theta minus mg sin theta. So since there is a force, net force in the upward direction, friction force will be down the plane, that's towards P. Option D says when theta is less than 45 degrees, friction force is towards Q. That's not true. It's towards P, which is downwards. So option D is wrong. So the only correct options are A and C. That is the correct answer. And there is one more clarification required here. For it to remain stationary, the net force when it's downwards and friction force is upwards, this net force which is acting downwards should be less than or equal to friction force maximum. Friction force will vary from 0 to a maximum value, and this maximum value is the coefficient of friction into the normal reaction of the surface. So just this condition is not sufficient for it to remain stationary. If theta is greater than 45 degrees, this condition also should be satisfied for it to remain stationary. Because if it is net force is downwards and the friction force is not sufficient, means it will go down. But the friction force is sufficient to stop the block from going down. So this means that the net downward force, that is sine minus cos, should be less than or equal to the friction force, which is mu. The normal reaction. Normal reaction is mg cos theta plus 1 sin theta. Mg sin theta is here, mg cos theta is here. So mg cos theta will opposite normal reaction, and 1 cos theta is along the plane, 1 sin theta is downward. So normal reaction is mg cos theta plus 1 sin theta. And mg is 1 because mass is 0.1 and g is 10. So mu should be greater than or equal to sine minus cos by sine plus cos. Okay, and since theta is greater than 45 degrees, we are here. So sine minus cos is positive number. So this is a positive quantity. So it's possible, but the surface should be rough enough that mu should be greater than this one, this value for a given theta. Only then the block will be stationary. So option C is true, provided this condition is satisfied. If the coefficient of friction mu is greater than or equal to sine minus cos by sine plus cos. So this is what I explained here. So the force is acting on this block of the weight mg, because gravity is downwards, normal reaction, and the applied force. So along the plane, the weight component is mg sin theta, mg cos theta is here, and then this applied force 1 cos theta is in the upward direction along the plane. So along the plane, the forces are mg sin theta downwards and 1 cos theta upwards, and of course friction force is there. So case 1, leaving out the friction, both this upward force and downward force are equal, and mass is 0.1, g is 10. So that means theta is 45 degrees. So when theta is 45 degrees, this condition is satisfied. So in this particular case, net force is 0, net of this downwards and upwards. So friction force is 0. So it is possible to remain stationary. So option A is true. Second case is the downward force, which is the weight component, is more compared to the applied force component, which is up of the plane. So this means theta is greater than 45 degrees, because sin theta is greater than cos theta, which is true in the 0 to 45 degrees. Sorry, 45 to 90 degrees. Sin theta greater than cos theta when theta is between 45 to 90. Okay, so in this case, the net downward force is mg sin theta minus cos theta, which is greater than 0 because sin minus cos. So this means the friction force is upwards towards Q. So option C is true, option B is wrong. And one more condition should be satisfied for it to remain stationary. The net downward force should be less than the friction force maximum. Otherwise, the thing will slide down. So this addition condition has to be satisfied. So net downward force should be less than the friction force maximum. Maximum friction force is mu in the normal reaction. Normal reaction is the weight component, normal to the plane, which is mg cos theta, and the applied force, normal to the plane, is 1 sin theta. So normal reaction is sum of these two. So this means the net downward force mg sin theta minus cos theta, weight component minus the applied force component, should be less than or equal to mu into n. So that means the roughness should be greater than sin minus cos by cos plus sin. So this is coefficient of friction, which is the indication of roughness of the surface. So, and here theta is greater than 45 degrees, so sin is greater than cos, so this is a positive quantity, so this is fine. So, but mu should satisfy this condition for it to remain stationary. Third case, the net upward force or the applied component force in the upward direction should be greater than the downward force, which is weight component. This means theta is less than 45 degrees because cos theta is more compared to sin theta, which is possible from 0 to 45 degrees. Then our about force is 1 cos theta minus mg sin theta, which is greater than 0 because cos is greater than sin for this value of theta. So the friction force will be downwards towards P. So option D is not true.